What is the hottest place in the universe? This is gonna blow. It's on Earth. I already did this bit with the coldest place in the universe video. It's on Earth. It is, in fact, the Large Hadron Collider at CERN. That's in Geneva, Switzerland, by the way, for the people who don't know. In 2012, they did an experiment there that got up to temperatures of 5.5 trillion Kelvin. They were smashing lead ions together to create a quark-gluon plasma, which is a state of matter that only existed shortly after the Big Bang. For comparison, supernovas, exploding stars, are only about 100 billion Kelvin. And we could get hotter. We could get much hotter. In fact, there is a theoretical maximum temperature for the universe, and it is 1.4 times 10 to the 32nd Kelvin. Any temperature above that, the laws of physics will cease to exist. Like, the very understanding, the very essence of matter and energy will completely break down, even on the lowest level, like at quark level. And what's this called? Absolute hot. It's also called the Hague-Dorn temperature, but absolute hot is a much more interesting name. And here's a real mind blow. We could theoretically get hotter than absolute hot, but not by making things hotter. To do that, we actually have to create temperatures in negative Kelvin. Now, this might not make a whole lot of sense to you because we can't reach absolute zero, so how do you get to negative Kelvin? You actually don't do it by making things colder. In fact, negative Kelvin temperatures are absurdly hot. And we actually created quantum gas with a negative Kelvin temperature in 2013. And to understand how this works, you have to forget hot and cold for a second. You have to just think about how temperature is atoms and molecules moving. So for positive temperatures, when you put energy into something, it moves more. You increase its energy, its temperature goes up. Now for negative temperatures, and this is a vast simplification, so quantum physicists, don't come at me, it's basically the opposite. If you put energy into something, it will slow down. And if you remove energy from it, it will heat up. It basically has an inverse relationship to heat as we do in positive temperature. And they have the potential to be the hottest systems in the universe because they don't just cool down, they heat up at rest. Or rather, as their energy dissipates out into the universe, their atoms don't move slower, they move faster, and thus heat up. It is another major mindfucky part of temperature physics. And it's really, really cool. Or really, really hot. It's one of the two.